In this part of the module, we'll use some practical examples to examine using arithmetic functions with matrices. Again, let's continue looking at our force plate data. An issue you will probably come across when working with this kind of data is bias. Once you've determined how much bias there is, or what the value is for the bias, it's pretty easy to remove. Let's assume that bias in this case is 0.00025. And you want to remove that amount from each piece of data in each column, in each row. So let's type data underscore bias underscore xyzt equals cat data underscore xyzt all rows, columns 1 to 3 minus 0.00025 and let's keep our time column in here by selecting all the rows and column 4. Okay, so close both brackets, semicolon, and enter. I'm going to take a quick look. Time hasn't changed. See the data in these 3 columns have decreased by 0.00025. You may also be asked to scale your data. For this module, let's pretend we've been asked to scale our data by a factor of 10. Let's first create our variable. So, where's cat? Data underscore bias xyzt. Since we assume the adjustments here will be accumulative, we use the data that's been corrected for bias before we scale it. You can just as easily use the original data underscore xyzt by entering that information here as well. Since we're going to be scaling all 3 coordinates, x, y, and z, or columns 1 to 3, we'll enter all the rows for columns 1 to 3, multiplying each by 10, comma, and like before, to maintain the time as part of to maintain time in the 4th column, you can enter data underscore bias underscore xyzt all rows for column 4. And enter. So you can take a look here. If you compare our data, you can see that the numbers have increased by a factor of 10. Except for the 4th column, which is time. If for some reason you wanted to scale each column individually, you'd go about it in a similar fashion. Except you would change this part here. So let's increase the 1st column by a factor of 10. the second by a factor of 5. And the third by a factor of 2. And something else we can try is converting this raw data to newtons. To do that, you need to know the sensitivity multiplier. You take the raw data multiplied by the sensitivity multiplier times 100 to convert this data to newtons. So for column 1, or x, let's assume that the sensitivity multiplier is 1.4851. So let's try that. We want all the rows in column 1 to be multiplied by 1.4851 multiplied again by 100 and semicolon. And for the second column, which is y, column 2, we have a multiplier of 1.4965. Again, enter. And for column 3, which is column Z, with a multiplier of 5.8246, and again enter. Now columns 1 through 3 are in newtons. I need to put all this back. Just type horsecat data underscore newtons underscore x data underscore newtons underscore y data underscore newtons underscore z, and data underscore scale 10 underscore xyzt. This is really want the fourth column. Do all the rows in column 4. Okay, we've now closed off all the brackets and enter. So we see here we now have data in newtons for x, y, z, t, 200 rows, 4 columns. Here we go, x, y, z, and time. Of course, you can also do the same thing in one step. We entered in a lot of information, so it might be good to also just check through, make sure everything is put in properly. So again, data underscore newtons underscore xyzt. First got data underscore scale 10 xyzt, taking all the rows from column 1, multiplied by the sensitivity multiplier times 100. Again, data underscore scale 10 underscore xyzt, all the rows in column 2, multiplied by its corresponding multiplier, and 100. And data underscore scale 10 again, xyzt, all the rows in column 3, multiplied by its sensitivity multiplier, and again by 100. And to bring time back in, data underscore scale 10 underscore xyzt, all the rows in column 4, and enter. One last thing we can try. If during your initial data collection you oversampled, and you have a larger file that's a bit too hard to work with, and you ended up with a lot more rows than you wanted, and you ended up with a larger file than you wanted, you can downsample or decrease the size of that file by using the colon operator to create a smaller version. So let's try that now. So we have data underscore newtons underscore xyzt. So starting with the 10th row and selecting every 10th row up to 200 with all columns still intact, and enter. We've now created a file that's 20 rows by 4 columns, in effect decreasing the file size by a factor of 10. And when doing this, you also want to make sure you don't decrease the file size by too much, so it actually impacts the quality of your data. If you were to downsample too much, you could lose important data, which could influence your results negatively. You'll learn more about downsampling and filtering in later modules. So this is the end of this module. So again, remember to check out the questions and do-it-yourself exercises just below this this video. When you've done those, don't forget to go back to the Moodle site to take your quiz and answer a few questions about this module. Thank you.